Just a quick piece of bonus content for you today, which concerns something that just terrifies a whole bunch of otherwise normal men. The prospect is you've got to drill a decent hole in a big chunk of solid steel like this. This is a piece of 63 by 12 hot rolled low carbon steel, like structural steel, okay? The cheese of steel, in other words. And one need not be terrified about that at all. So this is the kind of section that you might cut up into bits and weld posts on so that they could then go and be the posts that support a balustrade at the edge of a concrete slab or something of that nature, right? You might also use this in numerous structural sort of applications that are automotive or to do with caravans or trailers or something of that nature. It's a nice solid piece of steel without being ridiculously huge. And sometimes you can't get a piece of steel into your workshop to use a drill press, for example. And you know, it's nice if you can because drill presses are better, and you might not have a mag drill, or the piece of steel might not be big enough to use the mag drill with, blah, blah, blah. Sometimes you might have to get up to the top of some ladder or on a piece of scaffolding to work on whatever. And the only option is prosumer battery drill. And I gotta say, dude, it's gonna be fine. You don't even need special drills. You'd need reasonably high quality, high speed steel twist drills, but they're the kinds of things that you'd buy in the middle of the range at Bunnings, and they will get you by just fine. So here's how we're gonna do it, right? This is just a hypothetical. I'm gonna start from marking it out, getting the hole in the right spot, stopping the drill from wandering, getting it nice and square, and all of that stuff. So tip number one is stop marking out the hole with one of these, okay? Not accurate enough. Accurate enough for wood, perhaps, but not accurate enough for steel. So let's say I need a hole that's 25 in and in the middle laterally on this piece of steel. I am going to use my marker, but I'm just going to give a little bit of relief here so that I can see what the hell I'm marking out. And that's going to be the end of the marker, because then what I'm going to need is my trusty scriber. And if you don't have a carbide scriber, like, dude, where have you been all your life? But go and get one. But if you don't, you could use one of those snap-off marking knives, you know, like a box cutter. They work just fine in a pinch as well. And then you need something to mark the dimensions. And my favorite thing to mark the dimensions, particularly these offset kind of dimensions, is this baby. These are fantastic. They're like one of the world's best kept secrets. So I'm just going to whip this into the vise, and all you do is you whip your reference surface over here, and then you just give it a nice scribe. Now, when you've got a scriber like this, you don't put it vertical because the point will be off the edge. It's good practice to pinch it in like this and make sure that the point is right in at the corner where the ruler, if you like, where the fence is touching the steel. So just get it in at a bit of an angle, like 20 or 30 degrees to the vertical, and give it a nice big scribe, because you're not just trying to draw a line, you're trying to carve a little groove into the steel with your tungsten carbide tip, okay? And if you don't have one of these, that's cool too, because one of the tools everyone should have is one of these combination square jiggers, okay? They are fantastic. The engineering ones with the precision ground surfaces and the really nice fit, they're nice to have, but you could certainly get by with your Bunnings special. Near enough will be good enough in this case. So I've got this set to 25, so we're just going to do the same thing and carve another little trench in here. I'm just going to make sure that the fence is sitting flush on the edge of the steel, and I'm just going to give it another scribe like that. Then I've got a cross in the middle of the steel, which is exactly what I want. It's really cool at this point if you can get yourself a spring-loaded center punch, because that makes the next part of this job dead easy. And I'm pretty blind up close now, hence these. But you can do this by feel, because what you're doing is you're going to feel for the two trenches that you just dug in the steel with your scriber. So you can just make sure that the point is sharp. And if the point's not sharp, then just tweak it on your bench grinder so that it's nice and sharp, okay? You just feel for one of your trenches, you get it in there and then you slide down and you feel the other one. You can feel it straight away and you bang on. You don't need good visual reference to do this because it's more accurate if you feel it. And then just, there's your little pinprick and it is bang on in the center, okay? Next thing you got to do is you got to get a more serious center punch, which is just there behind you. And then all you do is you feel for your pinprick. You just drop the point in there into that little divot that you just made. And our next objective is we're just going to make the divot bigger. Bonus, okay? So that's enough to stop even the most recalcitrant drill bit from wandering when we kick things off. That's kind of important. So the point of doing all this is just to locate the tip of the drill and get it started. And now what I'm going to do, because it's always a little bit compromised when you do this by hand. Much better in a drill press, but hey, if you've only got a few of these to do, there is absolutely no problem just doing it by battery drill. So the next thing we've got to do is we've got to make sure that we're square. This is kind of important, you know. Making sure that we're not at an angle is really important, and I am going to need my glasses for this next bit. So what we're going to do is we're going to get just an offcut of a piece of angle, and it's going to be our squareness guide when we actually drill the hole, all right? So I'm going to get it down here and just make sure that this vertical axis of the angle is just underneath the hole, and I'm going to kind of get it lined up where I think the drill's just going to sit on top. And then I'm going to get my drill and I'm going to sit it in there into the divot that we just cut. And once it's in there like that, I'm just going to manipulate the position of that piece of angle until the drill is square both ways. Then I'm going to just drop the drill for a sec and make sure that the angle doesn't move while I grab my trusty clamp. All right, so we've got our guide in and there's absolutely no reason why we can't just start drilling at this point. It's going to be a good idea right now, he said, casting around, to use a bit of oil because oil's a lubricant and friction is just one of those things that really does impact on drilling, okay? Particularly if you're using a battery drill, because you're going to be limited by the amount of torque that can be applied. It's not so important when you're using a mag drill like this or a drill press because you've got a lot of torque, but with a battery drill, not so much. So knocking back the friction is going to be kind of important. Just make the job a little bit easier, it'll go a bit quicker, okay? So what we're going to do is, safety specs are a must for this, not so much because the chips are that dangerous, because they're not, but if you manage to break the drill for whatever reason, high-speed steel, under pressure, fracturing, never good. Okay, so safety specs absolutely essential. What I'm going to do is I'm just going to feel for that divot and get everything started. Then I'm going to get along here and I'm going to have a look both ways at the position of the drill relative to the fence that we've set up. And then I'm going to set myself up so that it's mainly my body leaning forward on the drill that is going to supply the pressure, okay? And once I've got that kind of locked in, I'm going to give myself a little bit of lube there on the drill. I'm just going to nudge that around so it doesn't evaporate too quickly. I'm going to get back to square, and then with my body basically locked in place and I'm nice and low and pressing in mainly with the weight of my body, I'm not going to fatigue that easily by doing that. I'm just going to get started. So I'll run the timer and we'll see how long this actually takes. Okay, we're getting there. I'm just going to use a little bit more oil now. Well, I'm not sure I'd want to do that all day long, but it really wasn't exactly that onerous. So we can get rid of the fence. We don't need that anymore. And we'll think about the next steps for what we want to do here, because we want to get a thread in there for M10, and then we want to check it and see how we went, see how vertical the bolt ends up being, because It's never good if the bolt head sits like that and the metal sits like that. So we want to make sure that it's nice and accurate and just see how it went otherwise. Okay, so the endless glamour and high-tech miracle of video production. It's the next day and I'm about to hit export, but it strikes me that there's a couple of things I should have mentioned yesterday, which was just a few seconds ago for you. Number one is, if your drill starts squealing like a deleted scene from frickin' Deliverance, that is reality reaching out to you, dude, and grabbing you by the lapels and pulling you in and saying, hey, I'm blunt. And if you've got a blunt drill, it's okay for wood, you can muscle it through, but with steel, it's actually very difficult. So you've got to do one of two things, replace it or sharpen it. And I've lost count of the number of conversations I've had with dudes who throw their drills away when they get blunt. And it's kind of expensive because they can be sharpened very easily, which is a subject perhaps for another video. But you can buy a jig, a machine if you like, quite cheap for about $100, and it's got a diamond wheel and all the heavy lifting is just taken care of. You just need to put the drill in the right way and rotate it around a bit, and all of a sudden what emerges is an undeliverance drill. So that's kind of nice. If you've got a bench grinder, you can do it manually. It's not that hard, but you'll probably need to devote about an hour of your life learning the process. And if you've got a belt grinder, that is just Goldilocks, because that would be my preferred device for sharpening a drill. You can get a really good result. You can split point and at least grind the reliefs in the other end, whatever. That's quite nice. Now, the other thing that I really need to mention, that I didn't mention yesterday / a few seconds ago, depending on who you are, is what about a pilot hole? Because there's gonna be endless geniuses out there in the comments going, you should have drilled a pilot hole. What are you talking about, dude? Dude, drill a pilot hole if you want, but I generally wouldn't bother if the diameter that you're drilling with a manual sort of battery drill is less than about 10 millimeters, because it's not going to be that much of an advantage. And the thing about a pilot hole is, what you're trying to do ultimately is save time. All right, so to drill a pilot hole, let's say you've got 4 holes to drill, you're going to drill a pilot hole. That's going to mean probably 4 tool changes. You're going to have to go from pilot hole to full-sized hole 4 times, right? Which is just going to get old, and it's not going to save you that much time, because you're going to have to subtract all the time that it takes to drill the pilot hole. So what is a pilot hole? Let's say, just using this big drill, this is a 25mm drill as an example, but using it, there's a part of this drill here between the 2 cutting edges, right on the point, which is called, unsurprisingly, the chisel point. And it's kind of an engineering artifact. It's only there because you need some meat in here between the 2 flutes. Otherwise, between the 2 flutes, you can see that here between the 2 flutes. If there was no thickness here, there'd be no chisel point, but problematically, your drill would frickin' fall apart. And the problem with the chisel point is it doesn't cut. It just smears metal out of the way. So the bigger the drill, the bigger the chisel point, the more friction is lost to just smearing with the chisel point. And this is really going to be significant if you're doing it by hand above about 10 millimeters. And you can do that, sure, you can drill a pilot hole. The diameter of the pilot hole really only needs to be slightly larger than the chisel point, because all you want to do is remove the chisel point from play. But you'd really like to have as much of these cutting edges here engaged as possible, because there's another old wives' tale with drilling that says just start at, say, 4 millimeters and then do 5, 6, 7, and 8.5 or something. Go up in little tiny increments. And I would have to retort respectfully that this is emphatic bullshit, because if you do that, what happens is you put a great deal of stress right on this corner here, and it's really likely to chip. So I wouldn't do that. The risk with a pilot hole, obviously, is that it's a nice thin drill, so when you're muscling into it by hand, there's a chance that you're going to break the drill, which just gets old, okay? So I generally use a pilot hole of 4, 4.5, 5 millimeters, something like that, but I wouldn't bother unless it was really hard with the finished size by hand. If it was a real strain and you could tell that the whole thing was struggling despite having nice sharp drill bit, then yeah, try a pilot hole and see if that helps, right? But if it doesn't, then you've got something else wrong with the process, and I'd suggest that a pilot hole is really only going to be beneficial in the context of drilling like we just did back there by hand with a battery drill if the size of the hole is 10 millimeters or greater. And I wouldn't go much smaller than about 4 millimeters, because when you're really muscling into it with a drill, unless you're super stable and very experienced, if you're using a 3 millimeter drill or 2.5, whatever, then you're just likely to break it. But anyway, that's what I meant to tell you yesterday and didn't even realize that I didn't say it, which is why I'm saying it now. All right, so that's an 8.5 mil hole, and the reason I drilled 8.5 is because it's the tapping size for M10 by 1.5, which is the standard M10 like metric coarse thread that you will see if you go and have a look at Bunnings and you want to buy some galvanized M10 bolts. In fact, I've got one of them here, and that's what we're going to use to check the accuracy of the hole I just drilled, just to prove to you that you can do a reasonable job just by using a few fairly standard tools. You don't have to go and set yourself up with a tool making workshop or anything of that nature to get this right. But what I've got here is a cheap, nasty, chatty 10 millimeter tap, and I don't know how much torque that's going to take to break, so I'm going to be really gentle with the tapping process, because in practice it is such a bastard to break a tap. It's just something best avoided, I think you'd agree. So here we go. We're just going to get this thread in here as quickly and as easily as we possibly can. I'm just going to back it off occasionally to make sure that we don't snap the tap, but that was pretty easy. And here we go. You only need to use one of the 3 taps. The taps come in sets of 3. There's a taper tap and an intermediate and a plug tap, but the other 2 are really only necessary if you're drilling a blind hole. Other than that, you really don't need to worry about it. This is pretty much the cheapest tap set that money can buy, and not a real expensive drilling machine, and certainly not a real expensive twist drill either. The beauty of M10, of course, is you don't need to buy a special size drill, because most drill indexes have metric half sizes, so 8, 8.5, 9, 9.5, 10, like that. 8.5 is the tapping size for M10, so that's a bit Goldilocks. And if we just check the fit of our cheap-assed galvanised bolt from Bunnings, then that's not too shabby either. And there is a bit of play in these things, so if we just get our baby square and have a little look at that and just make sure that it qualifies as something that could be widely regarded as square enough in the engineering ghetto, then our work here is done. Of course, I wouldn't want to do this 50 times by hand this way, because it is actually quite hard work. But if you do need to get just 1 or 2 holes in a piece of steel, and it's really not convenient to get a mag drill in there, and it's really not convenient to drag it in and put it under the drill press, and all you've got out on location, you might be working on some busted thing out in the desert with your 4x4 or something of that nature, you really don't need too much special equipment to get these kinds of basic metalworking jobs done. And there's absolutely no need to be terrified of the whole working with drilling metal thing, because it's a lot simpler than it seems. And we're not talking about drilling exotic materials, because most of the steel that you have access to in a home hobby and out there in the boonies working on a farm or working on your 4x4 environment is going to be this low carbon stuff, right? And low carbon really is the camembert cheese of steel. No need to be terrified by it. And I was suitably impressed, because some of those chips were actually coming off like big, stringy, proper drilling chips. And that means we're cutting reasonably efficiently. Now, just for complete disambiguation, I had the drill on speed number 1 as opposed to speed number 2, and I had it in drill mode as opposed to screwing mode, and I had, I don't know if it matters in drill mode, but I had the clutch set to the maximum as well. So it was just giving me a reasonably good result, and I think you'd agree an 8.5mm hole is a reasonably serious hole to drill by hand in a piece of steel. Not fun, but definitely doable. No need to be terrified any longer, dude. I'll leave you with it.